Okay, in this movie we want to be able to quickly determine the gravity at any location above the Earth. So if I have the Earth here, and I could be at any location, so if I'm right here on the surface of the Earth, we actually know, it's going to be kind of ugly, but we'll make the Earth here, and we know from the center to here is the radius of the Earth. And we actually know what gravity is right here on the surface of the Earth, don't we? It's 9.81 meters per second squared. Okay, but what if I'm clear up here at another place? And what's the gravity up here, G2? Or maybe further away, what's the gravity here at G3? And so we know from Newton's universal law of gravitation that the further away the object and the planet get, the less force there's going to be between them, which of course means there's less gravity there's going to be. We figured out in the last video, if you haven't watched it, you might want to watch it, that gravity equals big G times the mass of the planet divided by the usually the radius of the planet squared, but we'll just call it the distance between any two objects, but divided by the distance squared between the two objects. So what this means here then is, like in this case, instead of the mass of the planet, we're just going to call this the mass of the Earth, because we're really talking about how to figure out gravity at any location from the center of the Earth. So if we take this equation that we had for gravity and we multiply both sides by d squared, I'll have gravity times d squared equals big G times the mass of the Earth. Okay? And what you'll notice about this is that if I take gravity at some location, so I could take it, figure out what gravity is here, here, or here. If I take gravity at some location and I multiply it by the distance to that location squared, so that means if I'm going to use gravity of 9.81, I'm going to take it times the radius of the Earth squared. If I take gravity at G2, I'm going to take it times the distance from here down to here squared. Or if I take the gravity here, I'm going to take the distance from here down to here squared. So no matter what I do, no matter which gravity I choose and I multiply it by whatever distance squared to that location, it's going to always be the same thing. And this thing here is big G times the mass of the Earth, which is always going to be constant. For every one of these situations, that's always constant. Which means I can think of a quick little ratio, because I could have gravity, and we'll call it gravity 1. So gravity at any place times the distance to that place squared. So if I choose gravity here, I'm going to take that gravity times this distance squared. That will equal gravity, anywhere else, like right here, we'll call that G2, times the distance out to that place squared, D2 squared. Or that would then equal gravity, anywhere else, G3, like clear out here, times the distance from the center of the Earth out to that place, D3 squared. Because any gravity at any place times the distance to it squared is always going to be a constant. It's going to be the big G times the mass of the Earth. And we don't really need to worry about what that is. We can set, because if A equals B and B equals C, then A equals C or something like that in math, right? So I can use this kind of ratio here to figure out the gravity at any location. Okay, so if we let's do a problem here. Let's do a problem. Let's say that we want to figure out what is gravity at a point that is 3,270 kilometers altitude. Altitude, that's important, altitude. Because altitude means above the surface of the Earth. So what is the radius? What is the radius of the Earth? It's something we should probably remember. Radius of the Earth equals 6,370 kilometers. 6,370 kilometers. So I want to figure out what is gravity at 3,270 kilometers above the surface of the Earth. Well, I can use this equation because I always know one of my gravities. I mean, I always know that the gravity on the surface of the Earth is 9.81. And I always know the radius of the Earth is 6,370 kilometers. So I always know one side of this equation. So I could put 9.81 times 6,370 kilometers squared. Now, you might have a question there because I left that in kilometers. I didn't put it in meters. Everything's supposed to usually be in meters. But I can leave this in kilometers because this is just a ratio. It's not really an equation. It's just a ratio, which means if I leave this distance in kilometers, then this other distance is going to be in kilometers also. So that will equal G2, which is what we're trying to find, gravity like somewhere else out here, times the distance out to it squared. And I could divide my distance squared underneath here. So what is the total distance? Well, it's going to be the radius of the Earth, 6,370, plus the altitude, 3,270, squared. It's going to be that distance squared. And if I plug this all in, I should get a gravity, a lot less than 9.81 because it's further away from the planet. And so if you plug this into your equation in your calculator, you should try it out. You get like 4.3 or something around there. 4.3 meters per second squared. So we can use this little ratio here to quickly figure out gravity at any location above the surface of the Earth, because we always know the left half of this. It's always going to be 9.81 times 6,370 squared if we want to leave them in kilometers. And that's going to always equal a new gravity times the distance out to it squared. Okay, so we'll do one more problem. I want to figure out at what altitude will gravity be 1? Where will it be 1 meter per second squared? Okay, so I'm looking for an altitude. So I can take this equation here, and I'm going to solve for d squared, right? I'm going to solve for d2. So I'm going to have g1, which is 9.81, times the distance to that place squared, 6,370 squared. And if I divide that by my new gravity, which G2, which is 1, so that's pretty easy, it's just 1. And then I want to figure out my distance out to that place. Well, I need to take the square root of this then. And if I take the square root of this, that's going to give me the distance out to that location. Okay, but that's the total distance from here all the way out to, let's say that we were trying to figure out G3. G3 was 1 meter per second squared. So this distance that this is going to give me is the distance from here all the way out to G3 location. But the question says, what is the altitude? So whatever I get for this answer right here, the square root is going to equal some d. I need to actually subtract the radius of the Earth to get just the altitude, because the question asks just for the altitude above the surface of the Earth. And if you do that into your calculator, you should get 13,581 or something kilometers is going to be the altitude above the Earth where gravity would be 1 meter per second squared. So this is a really important little ratio that we can use to figure out gravity at various locations above the surface of the Earth. And I hope that makes a lot of sense to you.